Carbon is a chemical element, and it is a non-metallic element, and it has the number 6 in the periodic table. It is in the 4th group, and it is in the 2nd period. That carbon is in the 2nd period means that it has 2 shells, and the 4th group means that it has 4 electrons in the outer shell, which indicates that it has 4 electrons available for chemical bonding. As shown here, you can see that carbon has the number 6, which indicates that it has 6 protons in the nucleus and that it has 6 electrons in total. The symbol for carbon is the letter C, which you also see here. The atomic mass is 12.01 and it is measured in units. To find out how many neutrons there is in the nucleus, you simply extract the atomic mass from 6, which is the number of protons, and it equals 6, which means that there are 6 neutrons in the nucleus. And as you see here, this is how carbon looks in real life as a solid mass, and the melting point of carbon is 3,500 degrees Celsius, and the boiling point is 4,827 degrees Celsius. And here you see a model of the chemical element carbon. You can see the 6 protons and the 6 neutrons in the nucleus, and then you can see that there are 2 shells, and in the first shell there is 2 electrons, and in the outer shell you can see the 4 electrons. Atoms of the same element that have different numbers of neutrons are called isotopes, and I want to tell about the isotopes of carbon. Carbon has 50 known isotopes, from 8C to 22C. As you can see here, I have taken 3 examples of some of the carbon isotopes. It is carbon-12, carbon-13 and carbon-14. These 3 carbon isotopes are also the ones which occur naturally. Carbon-12 is one of the 2 stable isotopes of carbon. Its mass number is 12 and it contains 6 protons, 6 neutrons and 6 electrons. Carbon-12 is also the most common isotope of carbon. Actually, 98% of the carbon on Earth is carbon-12. Carbon-13 is the 2nd stable isotope of carbon. Its mass number is 13 and it contains of 6 protons, 7 neutrons and 6 electrons. The last, carbon-14, which is a radioactive isotope, its mass number is 14 and it contains 6 protons, 8 neutrons and 6 electrons. And that it is radioactive also means that it is really unstable. Why atoms form ions is because atoms want 8 electrons in the outer shell, because they want to look like the noble gases. So typically for carbon to react, it shares its 4 outer electrons with other atoms. Carbon is really difficult when it comes to ions, because it's hard to find out whether it's a plus charge or a minus charge. The electronegativity of carbon is too small to form C-4 ions with most metals, and to form C+4 ions when it reacts with nonmetals. Therefore, carbon forms covalent bonds with many elements. Carbon also forms really strong single bonds, double bonds, and triple bonds. When carbon bonds with another element, you can think of this sharing as filling out the outer shell of carbon. Take, for example, natural gas. Its chemical name is methane, and the formula is CH4. Its structure looks like this, and these 4 bonds are the same length, and it's a chemical bond. Hydrogen has a single, quite lone electron, so these 4 hydrogens share their 4 electrons with the carbon atom. If you ignite the methane in the air, as your gas stove or gas furnace does, it reacts with oxygen to form carbon dioxide and water. And the chemical equation for that looks like this. And it is CH4 plus 2O2, and when it then is heated up, it forms CO2 and 2H2O. So the bottom line is that it is most common that carbon forms covalent bonds when it reacts with other chemicals. My experiment to carbon is called the carbon snake, and what it shows is that when you add sulfuric acid to the sugar, it creates carbon. So what he does is that he puts sugar in a glass, and then he puts sulfuric acid in the sugar, mix it up, and then what happens is that the sugar reacts with the concentrated sulfuric acid, and as the sugar turns black, it is being turned into carbon. The experiment releases a lot of heat while it takes place, and this is known as a dehydration reaction because water is removed from the sugar during the reaction. And as you can see here, the sugar is turned into carbon, and as the carbon grows, it reacts like a snake, which is why it's called the carbon snake. And here you can then see the chemical equation at the bottom. And first you have sugar as a solid mass, then you have the sulfuric acid as a liquid, and then you end up with carbon as a solid mass, and you end up with water as a gas and sulfuric acid as a gas. There are many limited uses of carbon in its elemental form, but once it combines with another element, it changes itself into a useful substance for several things. Carbon is used as a base for the ink in some printers. It is used in cooling systems and devices like refrigerators and air conditioners. Carbon is also used to manufacture many heat-resistant devices and tools and metal cutters. It is used as a decorative tool in many jewelry items. Carbon is used in the rim of automobiles as a black fume pigment. And then carbon can also be formed into graphite, which is one of the softest substances, and it consists of carbon. There are many industrial uses of graphite. For example, it is used as a lubricant for machinery and engines. Then there is diamond, which is one of the hardest substances known to man, and it also consists of carbon. Diamonds are commercially used for making jewelry, since these crystal-like rocks are rare in nature and diamonds are very precious. Apart from jewelry, diamonds are also used for making cutting instruments because of their hardness.